Hi students, all of you welcome. Welcome to Suneel Engineering Academy. I am Suneel Kumar Bandaru. Students, in this basic electronics through topic wise MCQ series, we have completed 4 sessions. This is the fifth one. If you want previous, you can watch in this YouTube channel by clicking on playlist. Okay. So let me check up to which we have completed. All these questions completed now. Yes. Now coming to rectified based questions. Here the number of diodes used in center tap full wave rectifier. Coming to this number of diodes, very important question and very easy question. In case of half wave rectifier, in case of full wave, center tap and bridge rectifier. Okay, so in half wave rectifier, just one only we use, center tap 2, bridge rectifier 4 diodes we are using. So center tap full wave they are asking, that is 2 diodes. So the answer is option B. Okay. So the answer is option B. Coming to the next question, guys. The maximum value of voltage Vm is equal to 10 volts. Then RMS value of half wave rectifier output. So coming to RMS values of half wave rectified output. Okay. So first of all, VRMS for half wave. In case of full wave, bridge center tap and bridge rectifier. Okay. So in case of half wave rectifier, what is the RMS value, guys? RMS is equal to Vm by 2. In case of center tap and bridge rectifier, both are same, Vm by root 2. Here also Vm by root. So they are asking for half wave rectifier, that is Vm by 2, that is 10 by 2, that is equal to. So the answer is option B. Okay. So answer is option B. Coming to the next question, guys. If they are asking average values, we average, are also VDC, VDC. For this half wave rectifier, Vm by 5 only. Here you can consider center tap 2 Vm by 5. It is also 2 Vm by. So RMS value is Vm by 2. Average value is Vm by 5. Okay. Coming to the next question. Form factor of half wave rectifier output. Form factor. F, F. Okay. We know very well the peak factor and form factor definitions. Peak factor. PF. Peak factor is nothing but, for example, if you can consider a wave. Okay. So this is the maximum value or peak value. After that, 0.63% is average value. Okay. And 0.707 is RMS value. Is RMS value. Okay. So just wait. I want to in full. You can consider a wave. Okay, this is the maximum value or peak value. Okay, and this is the RMS value. Okay, and 0.63 times 63% average. Okay, average value. So this is the maximum value, that is like 100%. VRMS is nothing but 0.707, that is 70.7. This is 0.63, that is 63%. Okay, so here peak factor. Peak factor as the name itself, it is associated with the peak value. That is, what are the peak values here? VP, VRMS are the peak values now. So VP by VRMS. The same way, form factor below 2 are nothing but VRMS by V average. So like that, you can simply remember V average. Okay. So in this case, if you want to get form factor VRMS for half wave rectifier, full wave rectifier, center tap, bridge. You can calculate half wave rectifier RMS value VM by 2, average value VM by pi. So that is VM cancel pi by 2, that is 3.14 by 2 means 1.57. So 1.57. Okay. So the answer is 1.57. Coming to the center tap. Center tap, same. If you can calculate VRMS and V average, then you will get 1.21. Okay, here also you will get 1.21. Same values for center tap and bridge. Okay, so if you don't want to remember, you can calculate. VRMS is nothing but VM by root 2 and V average is nothing but 2 VM by pi. Then you will get 1.21, 1.21. And peak factor. So peak factor is nothing but peak value by RMS value. Okay, peak factor is nothing but maximum value or peak value by RMS value. Okay, and what about the peak factor for this? Maximum value is VM. VRMS is nothing but VM by 2. That is nothing but peak factor is 2. So highest peak factor we have for this half wave rectifier output. Okay, in case of center tap, maximum value by VM by root 2, that is equal to root 2. You will get root 2. Okay, coming to the next question. Ripple factor of half wave rectifier output is dash. Ripple factor is denoted by gamma, that is root of form factor square minus 1. Okay, root of form factor square minus 1. Form factor is 1.57 now. Root 1.57 whole square minus 1. Then you will get the ripple factor is nothing but 1.21. Okay, so this is for half wave, and in case of full wave, center tap and bridge is 0.48, 0.4. Okay, so here 1.21. So the answer is option. Coming to the next question, the maximum efficiency of half wave rectifier output is dash. The maximum efficiency of half wave rectifier output is dash. So the maximum efficiency of half wave rectifier output is just 40.6%. Okay. In case of full wave rectifier, it is double, that is 81.2%. Just wait, I want to give a table. From the table, you can get all these terms easily. Just wait a little bit. Okay, so all of you note down it. Very important, guys. If you know, also try to note down the form of table. Okay, let us take some particulars. Is in case of half wave rectifier, here full wave rectifier. So in full wave rectifier, center tap, bridge. First of all, number of diodes. We know how many in half wave? 1. Center tap, 2. Bridge rectifier, 4. Okay, and VDC or average value. So for average value is VM by pi. Here 2 VM by pi. Here 2 Vm by 5. Okay. And RMS value. Vm by 2. Here Vm by root 2. Vm by root 2 by 2. Okay. Now coming to form factor. Form factor for this 1.57, for this 1.11, 1.11. Okay. And ripple factor. Just now we have discussed 1.21, 0.48, 0.48. Okay, 0.48. Now maximum efficiency. 0.48, sorry, 406, that means 40.6. Just wait. 40.6%, 81.2%, 81.2%. Okay. And peak inverse voltage. This is the very important. After rectifier input is just Vm. For center tap, its requirement is 2 Vm. So if you want to use 2 Vm of PIV, then cost of the diode is higher. That is the disadvantage in case of CD. PIV requirement is higher in center tap. That is a disadvantage of CT over than the bridge rectifier. Okay, 2 Vm, here Vm1. Okay, and ripple frequency. Here F, here 2F, here 2F. Okay, and coming to transformer utilization factor, very important, 0.287, 0.693, 0.812. Okay, 0.812. I think these are visible now. No. Okay, so note down. Okay, so that means the main differences are, this is the one of the difference between CD and bridge, and one more thing is PIV rating, and one more thing is transformer utilization factor. Okay, so these are the main differences. Note down and just wait a little bit after that. Okay, completed. Coming to the next question. The transformer utilization factor of center tap full wave rectifier. We have already discussed in half wave it is 0.287, center tap 0.693, and bridge rectifier 0.812. Na? So here center tap full wave rectifier 0.693. So the answer is option D. Okay. Coming to the next question. The PIV in center tap full wave rectifier. I have already given PIV for center tap. It is requirement is higher, that is nearly 2 Vm. So the answer is option B. Coming to the next one, a bridge rectifier uses 9 volts AC input voltage. The diodes are ideal, then DC output voltage. Bridge rectifier DC output VDC is equal to 2 Vm by 5. Okay, a bridge rectifier uses 9 volts AC input voltage. So whatever the input voltage, that is RMS value, that is 9 volts. So if you want maximum value is equal to root 2 into RMS. So that is 2 into root 2 into RMS. That is nothing but 9 volts by 3.14. Okay. So then approximate value 2 into 1.414 into 9 by 3.14. 18. Then what is the value? Come on, try to calculate. approximately 8.1 volt you will get. Let me check. 8.10. Yes, correct answer. So the answer is option B. Okay. So the answer is option B. Coming to the next question. The following which is heavily doped diode? Which is heavily doped diode? Heavily doped diodes are nothing but tunnel diode and also GNR diode. Here tunnel diode given. We have to go with the tunnel diode. Tunnel diode is very heavily doped diode. Okay. After that, GNR. Okay, and PN diode is lightly doped diode. Here doping concentration 1 is to 10 power 3. Here 1 is to 10 power 5. Here 1 is to 10 power 12 or 10 power 13, like that. Okay. So here tunnel diode is there. Because of this heavily doped, there is a tunneling will be done, which diode produces negative resistance region. Very important question. Negative resistance region. That means tunnel diode produces the negative resistance region. What is this negative resistance region? As voltage increases, the current decreases, then you can say that is the negative resistance. Okay, so in case of tunneling diode, as you can consider forward voltage, forward current. Here for low values of the voltage, as voltage increases, current also increases proportionality up to Vp. Okay, so that corresponding current is Ip. After that, if you further increase the voltage, then current will be decreases and to up to a certain limit. That is, that corresponding voltage is valley voltage and the corresponding current is valley current. Okay, valley current. And after that, if you further increase the voltage, then it will be increases again. So that means it will be act in three regions. For low voltage, this is ohmic region. For Vp to Vb, it is negative resistance region. Why negative resistance? As voltage increases, current is decreasing. So that's why it is negative resistance region. And this is the enlarged region. Enlarged region. Okay, enlarged region. So you can note down the points for low values of the voltage from 0 to A. It is as voltage increases, current also increases. Okay, so this is called as ohmic region. And for more than Vp, that is Vp to Vb, as voltage increases, current will be decreases. So this is called as negative resistance region. In this negative resistance region, it will be act as relaxation oscillator. So oscillator which can produce the AC. Okay, that means here also what is happening? Negative resistance. Resistance is negative means instead of absorbing, it is delivering. Instead of absorbing, it is delivering. Okay, so it can be act as the relaxation oscillator. That is a very important feature of this tunnel diode. Okay. Which of the following diode is act as relaxation oscillator? Just now I have given relaxation oscillator tunnel diode. Okay. The reverse bias tunnel diode act as dash. In case of reverse bias, it is as voltage increases in negative terms, current also increases in the same manner. So in reverse bias, it will be just act as the resistor. In reverse bias are low values of the voltage. Both case reverse is act as the resistor. Okay. Of Weyeractor diode. Weyeractor diode. So it is a diode having variable capacitor. Variable capacitor diode. So variable capacitor. So that's why it is also called as vari cap. Vari cap. So it is an ordinary diode with a variable capacitor. Okay, we can also give this one. Diode is represented as resistance and that variable capacitor. We can also represent like this, or we can also represent diode within itself. We have to make a capacitance and we can give like this. Here anode and it is the cathode. Okay, and this mode of operation depends upon the capacitance, that is transition capacitance. CT is nothing but transition capacitance which is present in reverse bias. Which is present in reverse bias. The CT is inversely proportional to reverse bias voltage, that is cubed root of reverse bias voltage plus knee voltage. If you can consider knee voltage as very less, that is cubed root of reverse bias voltage, or you can say VR power minus 1 by 3. Okay, VR power minus 1 by 3. That means generally CT is proportional to reverse bias voltage whole power n. For varactor diode it is 1 by 3. For varactor diode it is 1 by 3. So the capacitance present in reverse bias is considered as CT. That is the operating principle of varactor diode. So transition capacitance. That is nothing but here whenever, for example, if you can consider a normal diode. Okay, normal diode. What is happening? If you increase the reverse bias voltage, then the depletion layer width will be increases. As the depletion layer width increases, what happened to the capacitance? Distance increases means capacitance is decreases. So what they have given? The reverse bias voltage increases. As voltage increases, what will happen? Depletion layer width will be increases, then capacitance is going to be decreases. Okay, capacitance is going to be decreases. That means here the mode of operation is depends upon the capacitance, that is parameter. Capacitor is one of the parameter in the circuit now. So that's why it is also called as parametric amplifier. That is also a very important question. Varactor diode symbol is one question, also called as varicap. It is mode of operation is one important question. Okay, and coming to the next one is varactor diode is also called as linear graded diode. Linear graded diode. So here grading may be linearly. Okay, these are the very important questions. Coming to the next one. In the following, which diode act as parametric amplifier? Just now I said na parametric amplifier depends upon the parameter, so that is nothing but varactor diode. Answer is option C. And Schottky diode is the metal semiconductor diode. Okay, so if you take the metal and semiconductor on the other side, that is a Schottky diode. Okay, that is also very important diode. And which diode is a metal semiconductor diode? Just now I said na. Here, if you can consider one metal and another side, if you do with n-type material, then it will becomes metal. This is the metal, this is semiconductor. So metal semiconductor diode. Okay, that is Schottky diode. Schottky diode. The symbol is also. The symbols are very important. Schottky, the first letter yes na, yes for yes. So this is the symbol of Schottky diode. Okay, very important. Symbols are very important, guys. In most of the JEE examination, that is 80% of the questions are not difficult, guys. Very simple and basic level questions. Okay, basic level questions. We may not expect this much of simple question they will come in the they will give in the examination, but those questions will come in the examination. Okay, so the difficult questions are difficult for all, not only for you, difficult for all. Okay, the easy questions, we don't want to miss at least a single easy question. That is the main important thing. Okay, so generally after the exam, what we feel that whenever we see the answer key, oh shit, this much of simple question, how I have given the wrong answer, oh shit, like that we are feeling. Okay, we don't want to feel like that. Okay, we have to give correct answer for easy questions. Then only our selection will be very easy. Okay, our selection will be very easy. So don't miss easy questions. Okay, so try to prepare all the basic levels. Coming to the next question, in the following which diode having reverse recovery time is 0? Reverse recovery time is 0. In case of ordinary diode, what is happening? One side is p type, one side is n type, so depletion layer is formed. Due to the depletion layer, some capacitance is formed, correct? Whenever there is a two parallel plates and between the dielectric is there, capacitance is formed. Whenever the capacitance is formed, then the time constant capacitance is there. That means due to the capacitance, time will be increases. Time constant is RC. So as capacitance increases, that is the time taken will be also increases. That means here whenever there is a capacitance is there, then it takes a lot of time to recover. Okay. So but in case of metal semiconductor diode, I mean Schottky diode, metal semiconductor. In case of metal semiconductor, there is not like a depletion layer is formed. Okay, so there is no depletion layer. Only here metal plus semiconductor. So metal in the sense only electrons, no holes. Only electrons, no holes. So there is no possibility of capacitance, and the time taking is also very less. So reverse recovering time is very less for in case of metal semiconductor diode, that is nothing but Schottky diode. Schottky diode. Very important question, guys. Which diode is linear graded diode? I have already given now. Varactor diode is a linear graded diode. In the following, which diode is used for electronic tuning applications? Very important question. Very important question. Which is used in electronic tuning applications? Where we are using, that is tuning application means we have to tune the inductive reactance to capacitive reactance. Then that is it will be in the resonance condition. It can give very good output or maximum output. Correct. So that means, for example, if we have in the circuit we have the inductance, if you can vary the capacitance, then Xc will be varies. Then you can tune both reactances now, both the reactances. So that means here where is the diode in which we can vary the capacitance, in the diode in which we can vary the reactance. Okay, so the diode is nothing but varactor diode. Here only we have the capacitance quantity is there now. So by using that variable capacitance, we can tune the circuit for our desired operation. Okay, so varactor diode is generally used in all the tuning applications. All tuning applications. Tuning applications. We use varactor diode. Okay, coming to the next one. Match the following. Match the list 1 with list 2 using the codes given below. Okay, here some of the students just watching blindly. So what I am saying is, take this one as a practice course. Okay, so whenever I have given the screen on the given the question on the screen, you have to try to give the answer. Okay, you have to try to note down your answer. After that, check with my answer. Okay, so in that way you have to attend for this session. Okay, now coming to the question, here ABCDs I have not given. Okay, it's not a problem. So whenever we have the matching type of the question, the best thing is we have to match what we know very well. Okay, so in all this silicon diode, germanium diode, LED, pin diode, high frequency, low reverse saturation current, low forward bias, cutoff wavelength. Wavelength is nothing but belongs to light, correct? So in this light, LED na, so C4, easily you can match. Okay, high frequency applications, we go with the pin diode. That is the speciality of the pin diode. It can be used for high frequency applications. Why? Because here in case of pin diode, we introduce one intrinsic layer between P and N. Then depletion layer will be more. then capacitance is less, then time will be less. So as time is less means it can be used for high frequency application. So pin diode is generally used in high frequency application. We can use this one. Now silicon diode and germanium diode. Okay, we know the differences in silicon and germanium. Here low forward bias voltage drop. Forward bias voltage drop. Here 0.3 for germanium, 0.7 for silicon. So low for germanium. So B3. And silicon only reverse saturation current. Yes, the leakage current is less. A2. So 2, 3, 4, 1. Like that we have to match. Okay, like that we have to match. First of all, we have to match what we know very well. After that, remaining will be very easy. Okay, coming to the next question, guys. Here they have given in the list one diode and their symbols. Okay, so it is a very easy one. GNR diode, as the name itself, Z. The symbol must having Z. Z symbol. So that is A1 is the correct answer. Tunnel diode, in both manner, it is both ends are in one direction with a T. So tunnel diode. So this is the same for tunnel diode. Schottky, S for yes. Yes, that means 3C. Photodiode. Here, so many students confuse the diode symbol of photodiode and LED. Remember one simple logic, guys. If we have the two diodes, photodiode means whenever the light fall. Okay, if you just imagine in general, photo means we have to click on any object, then some flash will be fall on that object, that is light is falling, so falling on this diode. Okay, falling on this diode. And LED, coming to the LED emits the light, correct? It gives the light, it produces the light. That means from the diode to light is producing outside direction. Okay, that is the simple thing. All of you clear? So don't confuse. Light is falling means photo, and LED diode is nothing but light is producing, that is, you can say, outward direction. Photodiode generally operated in reverse bias. This is the very repeated question, guys. Most repeated question in the photodiode. Photodiode is generally operated in reverse bias. Okay. And coming to the next question, the value of voltage across the diode in the figure is dash. The value of the voltage across the diode in the figure is dash. All the electrical students feel that whenever the question is belongs to diode, that is problem is belongs to diode. That means in the circuit, whenever we see the diode, what we will generally, you can share in the comment section. It is a foreign question. We don't want to attend this one. This is not belongs to ours. Okay, just we feel like that. But in all electrical exams, deciding factor is the electronics, guys. Why? Because all the students are very well in the electrical. Then all the students will get same marks now. Correct? Then how we can only get the job? That deciding factor is the electronics. Okay. So if you watch my previous sessions, all my previous sessions, after that you surely get the confidence. Very easy manner. I have given very easy manner. Okay, here also, whenever we have the problems, the solution is very simple. Just a small thing is nothing but diode is in forward bias or reverse bias. We have to check that one. That is only in the diode problems. Okay. I think you know very well the diode is in forward bias or reverse bias. Here positive is connected to negative, negative is connected to positive, opposite. That means it is in reverse bias now. Reverse bias means how the diode act. All of you, how the diode act? It will be act as open circuit. Okay, sir, it is a recording class and you are asking the question. How we can do the reply, sir? So don't feel like that. Feel it is a live class. Here, if I am asking reverse bias, how the diode act as, then within your mouth, you can within your mind, you can feel that, sir, it is a open circuit. Okay. Then the class is also like a virtual live class. Okay. And it is a forward bias. Forward bias. And don't worry, when when the RRB notification came, from that onwards, I will try to take a live classes also. No need of worry. Okay. So maximum I will try. In forward bias, we know diode is act as short circuit. That is only, we can easily eliminate the diode here. We can easily eliminate the diode. So here, reverse bias in the sense, diode is open. Whenever the diode is open, there is no current is flowing now. There is no current is flowing. That means whatever the voltage is there, that will be false across the diode only. Whenever there is no current is flowing, there is no voltage drop here. There is no voltage drop here. Okay. There is no voltage drop here. That means same whatever the voltage is there, that will be appears across these diodes only. Across these terminals only. That is 8 volts is the answer. Correct. If it is a forward bias, voltage across the diode is nothing but 8 volts. If it is in the forward bias. Okay, then resistance is required now. It is a forward bias. The forward bias means in that case the diode is in forward bias means it is act as a short circuit. Then across the diode, how much voltage appears? Across the diode is actually in ideal case 0 volts, but in practical case 0.7 volts if it is the silicon. Okay, 0.7 volt drop is there across the diode. Okay. And okay, students, we will discuss these some more examples in the next session. Oh, just wait, only 3 sessions. After the transistor is there now. Okay, let us continue. Come on, a very easy questions are there. Don't worry. Here, which diode they have given? In most of the examination, 99% they will give 2 type of questions. First one on PN junction, second one on GNOT diode. Sorry, PN diode, GNOT diode. Okay, they may not give other diode based questions. Okay, don't worry about that. Here V0. V0 is nothing but voltage across the diode. What is the first step I said? The diode is in forward bias or reverse bias. Positive is connected to positive, negative is connected to negative. So it is in the forward bias. Forward bias, it will be act as a same like a short circuit, ordinary diode. Okay, short means whatever the knee voltage or whatever the barrier voltage, that will be false across the voltage. Okay, so that is nothing but 0.7. So V0 is equal to barrier voltage, that is 0.7 volts. So the answer is option C. If they have particularly mentioned it is a germanium, then you can say 0.3. If they have mentioned ideal, if the diode is ideal, if the question, if the diode is ideal, then 0 volts. Okay, if they have not mentioned anything, means we have to consider it is a practical. Coming to the next question, here what is the V0 here? So positive is connected to negative, negative is connected to positive. It is reverse bias. In the reverse bias, how the GNOT diode will be act as? GNOT diode act as regulator, correct? Regulator, very important. Regulator in the sense, whatever the GNR voltage, that will be fall across the diode. So GNR voltage, they have given 10 volts means no need of thinking anything. Okay, V0 is equal to Vz. This is the Vz, that is equal to 10 volts. So the answer is option B. Okay, if they have given GNR voltage 20 volts, V0 is equal to 20. If it is 30 volts, V0 is equal to 30. Okay, if it is 39 volts, V0 is equal to 39 volts. Okay, if the Vz is equal to 50 volts, then what will be the answer? V0 is 50. No, that is not in GNR biasing. We have 3 rules are there. The circuit is in GNR biasing or not. That means it is acting as a voltage regulator or not. Okay, supply voltage always greater than the GNR voltage, and the current is always less than the maximum value of the current. Okay, so then only, and third condition or first condition, it must be in reverse bias. Okay, here reverse bias, supply voltage is less, so it is in the GNR biasing voltage. V0 is equal to Vz only, so we can give the answer as 10 volt. Coming to the next one. Here 2 diodes they have given. Don't worry, any diodes can give the answer very easily. We have to check just forward bias, reverse bias. First one positive, positive, negative, negative. First one is in forward bias. Forward bias means 0.7 volts drop. Positive to negative, negative to positive. It is in reverse bias. Reverse bias means here GNR voltage 10 volts. So both are in series. If the voltages are series, you can say, okay, we have to add them. 10.7 volts. Answer is option C. How much of simple this? Correct? Okay. Yes. Students, in the next session, we will start transistors based questions. In the transistors, we can feel this transistor is this much of simple. So many tricks. I will use the so many tricks to remember. Okay. I will give the concept and I will also give the tricks to remember. Okay. So don't forget to watch the next sessions. And one more thing, students. Some of the students just skipping the video, that is just opening the video and skipping the video. Okay, so those type of students, don't open my classes. Okay, so here I am giving the free classes and I am working on it. Okay, so don't waste my work. If at least some of the students get into the job, that may be reward for me. Okay, so I want you have to be get into the job. So don't miss any video. If you have the time to watch, then only open the video. Don't open and don't skip. If you want to skip, don't open. Okay. So if you don't want to sit 20 minutes or 30 minutes, then how we can get the job? Okay. Here, so many students are applying for a job. We have to be special among them. Then only we can get. How we can special? We have to prepare. That is only. Okay, correct or not? Here, that is, some laborers are doing labor work. Correct or not? Doctor is doing doctor work. In the same way, student work is nothing but preparation. There is no other. There is no other shortcuts. 90% preparation, 10% luck. Luck is not in our hand. Okay, so we have to prepare. So many students are feeling that, sir, I have written examination, I have given one examination. In that I have given 75 score, but cutoff is 77, sir. Just within 2 marks, I missed that one. I have attempted 20 questions. What I don't know, but 20 questions are wrong. There is no luck for me. In that case, you have to prepare, increase your preparation. Okay, try to get 85. Then in remaining 15 questions, if you don't get at least 1 mark also, you will be reached cutoff easily now. Okay, so don't feel about the luck. Just increase your preparation, then God will give us the luck. Okay.